In this video, we are going to evaluate the integral 2 over cotangent x over 2 plus tangent x over 2. We are going to integrate it in two different ways and you will see that they will give different answers. To solve the problem, we need to first consider the denominator. It seems complicated and hence the life would be easier to simplify the expression. Using the basic definition of tangent and cotangent, we can express both of them in terms of cosine and sine. Then we simplify the expression by finding a common denominator. Since sine squared theta plus cosine squared theta is equal to 1. So cotangent of x over 2 plus tangent of x over 2 is equal to 1 over sine x over 2 cosine x over 2. Now put it back to the integral, we need to compute the integral of 2 sine x over 2 cosine x over 2. Now recall the double angle formula for sine 2x, we see that 2 sine x over 2 cosine x over 2 is equal to sine x. Therefore the integral is negative cosine x plus constant. Even though we have found the answer, just as I promised, we can do this in another way. Notice that at this step, we can integrate using chain rule. Since differentiate sine x over 2 gives a half cosine x over 2, so the integral of 2 sine x over 2 cosine x over 2 gives 2 sine x over 2 squared plus a constant. How come the function can have two different integrals? Recall the double angle formula for cosine 2 theta. We see that it is identical to 1 minus 2 sine squared theta. So we can deduce that negative cosine x is equal to 2 sine squared x over 2 minus 1. Therefore, in fact the curve negative cosine x is a translation of the curve 2 sine squared x over 2 by negative 1 unit in the y direction. This means that only the constant is different between the two curves. In fact, d is equal to c minus 1. This reminds us that constants do not affect the derivative of a function. Moreover, an integrable function can have infinitely many integrals just by altering the constants. Therefore, it is very important to include a term for constants in an indefinite integral problem. This marks the end of this video. If you like the content, feel free to leave a comment and subscribe the channel. Hope I will see you next time.